Okay, so these are homework problems that pertain to the last two videos. Cobb-Douglas, linear, the linear one, and the L-shaped is not on here. Yes, but let's just kind of take a look at what we do here. Yeah, so let's do A. So remember, for A, if we want, all we have to do is compare their slopes, the slope of the contour lines and the slope of him. But what is the slope of the contour line? So it will be given by, we have x2 and x1, but this one actually uses x and y there. So delta y over delta x equals negative partial of f, yeah, with respect to x over partial of f with respect to y. Yeah. So we're just plugging into that. We have to remember that. It's very easy, but seems very difficult. Yes. But the slope, so delta y over delta x, yes, is going to be, what is the partial? We could just say partial x. That's one way to do that is 2. Partial y is going to be 4. Yeah, so it is negative 2 over 4. We could just say m equals negative a half. So we erase this because it gets messy. But remember, if we have these things, the m there is going to be negative a half of the contour lines. We're basically done. This is not a thing. This guy here, he's less than negative x plus 2. Yes, we have it right there. That's negative 1. What do we have? It's the steepness, down 1 over 2. Yeah, that's how steep. And then we have down 1 over 1, down 1. Yeah, that's definitely more steep, something like this. So it is a guarantee, yes, that it's going to be there. That's going to be the x equals 0 right there. Yeah. So when we plug it in here, when x equals 0, y is less than or equal to 2. That is the point 0, comma 2. And we have to plug it in here. Yeah. So we do get x equals 0 and y equals 2. That's part of our answer. And then we have f of 0, comma 2 equals 2, 0 plus 4, 2, which equals 8. Yep. So it is 8. We have x equals 0, y equals 2, and our max, f of 0, comma 2, 2 equals 8. So A is just kind of a warm-up exercise, yes. Okay, so for B, and it's really going to be B, C, and D, we have to kind of use some intuition. They're all going to be Cobb-Douglas. This isn't, the pictures might get more difficult in this, but remember, if we have a contour line, see, that's the problem. I said, find the contour line, but we can't because in these problems, we're not setting the height equal to something. We're not doing that. That's silly. Set the height equal to something. We're maximizing that. It wouldn't make sense to set that equal. We're trying to find the maximum of that. That is what we're trying to find. But we have the contour line, which is what we have, um, at a certain height. The contour line is at the same height. Yes, we have the contour line, and we know that we have the y equals mx plus b, our constraint, to draw it pretty well. That's not a very good. But we know that they're going to intersect at a point, and we know that point of intersection is always going to be the height, yes? So we have to kind of we don't have to graph it. I'm just using the graph for B. It's for B, C, and D, but we're doing B. Yeah. We have to know that basic intuition. What am I talking about if it wasn't obvious from all the videos, all the kind of nonsense we went through, just take away a few points, yeah? But Do we kind of understand that basic thing? Remember when they had that point A? Do you remember that basic thing? So the slope of the contour line, that is the, what do we call it? The constraint is tangent to the contour line. So the slope of the contour line is by that slope formula, and the slope of the y equals mx plus b is what it is. So if you just match up the slopes, that's going to be the point at which that works out. So we have to do it for b, take the partials. Yeah, the partial of f with respect to x for b. Partial with respect to x, remember, y is held constant, so it is y. The partial of f with respect to y is going to be x. Yeah, so remember the delta x, we're doing our little formula. I'm not going to write it because we already wrote it. Why do I write this stuff? Yeah, so this is yx. It has to be slope formula, which is the slope formula of a graph where this is y and this is x. So it has to be delta y over delta x equals negative the flip. It has to be the partial of x up top, which is y, and the partial of y on the bottom, which is x. Okay, so that right there is going to be the thing. And if we have y is less than or equal to negative x plus 2, right there. Yeah, so that's going to be the slope there. I said it was pretty simple, and it's really not. Um, so remember, this is the slope formula over here on the left, and we have our constraint. We have to take our slope from the constraint, which is just -1, and we have to set it equal to our slope formula. That's what we said a moment ago. So we get y over x equals 1, and we get the little equation y equals x. It's hard to see that, but this is the uh, this is kind of the slope thing. That is our contour line. Yeah, and then this is that. So if you set those two things equal, let's just erase everything. It's getting messy. But from that, we get x equals y. This is our constraint. We have y is less than or equal to 2 minus x. We have that. So then just plug in. If you plug in, we should get that x value, yeah. I know I'm using inequality. It doesn't really matter. We just want to say that x equals 1. Okay, so plug it on back in there. That's 1 plus y equals 2. That's y also equals 1. Yes. So the maximum is going to be where x and y equal 1. That's the answer to the problem there. Yes, so f of 1 comma 1 equals 1 times 1, which equals 1. That is the answer there. Okay, so C is similar, D is crazy hard. Let's just go ahead and save that for the next video there.